Hello, welcome to Group 24's presentation. Our team comprises of 5 people. In this presentation, we will discuss about the need to analyze the response to COVID-19 vaccine, how we crawled, built a search engine and classified the data. COVID-19 is an infectious disease that caught the world by storm. It resulted in crippling economies, endless lockdowns and a significant loss of human lives. With over 131 million confirmed cases and 2.85 million deaths worldwide, vaccines were developed in less than a year. However, some are concerned that the vaccines were rushed. This led to vaccine hesitancy. Only 2% of the world is currently vaccinated. This may be improved if public concerns towards the vaccine are addressed. To do so, our team built a search engine and performed sentiment analysis on the global response to COVID-19 using Twitter data. Firstly, we crawled 60,775 tweets related to the COVID-19 vaccine. From the tweets, we are able to obtain the following information. This table shows the number of records, words and types in the corpus. In the next section, we performed index and querying. The tweets are indexed using Solr. The query result was retrieved by calling the Solr API using Python requests library. Our web interface features the search engine built using the Django framework. Let's start searching our web interface. With our search engine, you are able to perform various types of query, such as term, phrase and Boolean query. It will display the relevant tweets and the time taken. By clicking on the Enhanced Search button, it will display word cloud which give greater prominence to words that appear more frequently, as well as bar chart, showing statistical details for the tweets retrieved. This table shows the time taken for all the queries performed. We can tell that phase query is actually the most computationally exhaustive as it takes the longest time of 26 milliseconds. The pre-processing steps we undertook are as follows: noise removal and normalization, removal of stop words, lemmatization of tweets, stemming of tweets and tokenization. It is imperative to carry out text pre-processing to ensure that the text data only has useful information, hence predictable and analyzable for our network and to allow proper feature extraction. We ran experiments using the naive Bayes, KNN, SVM and decision tree classifier using both the count vectorizer and TF-IDF vectorizer. Among all the comparison models, SVM using the TF-IDF vectorizer performs the best. Now let's look at 2 more models that we implemented. The model architectures of our proposed models are shown here. For the first model, a bidirectional long short-term memory network was implemented. The second model, BERT, is a transformer-based machine learning technique for natural language processing pre-training developed by Google. Between the proposed models, the fine-tuned BERT model achieved the highest scores of 0.952. It also performs better than our comparison models and measures up to the SVM classifier. Thus, this shows that our proposed models are effective in classifying the tweet's sentiments. Next, we performed enhanced classification. Aspect-based sentiment analysis is incorporated in our BI-LSTM model. It identifies the sentiment attributed to each category and implicitly connect aspects with opinions, which improves the result. Secondly, we implemented ensemble learning using random forest classifier. A random forest is a meta-estimator. It fits a number of decision tree classifiers on various subsamples of the dataset and uses averaging to improve the predictive accuracy and control over fitting. To visualize the data, we used word cloud, topic modeling and geospatial analysis. These visualize present data in a way that is compelling for users to understand and derive crucial information. In this project, we performed crawling to retrieve Twitter data related to the COVID-19 vaccine. With the data, we indexed it using Solr and created a web search engine. Lastly, we performed sentiment classification using various models and visualized the classified data. Thank you.